Hi everyone, so now we're going to talk about imaginary number modulus, which is just a fancy word a fancy phrase of saying I want to find the absolute value of an imaginary number or a complex number. We like finding the absolute values of complex numbers because it tells us the distance between 0 and that complex number. In the next lesson, we're going to graph imaginary numbers, and so this absolute value would tell us the distance between the origin and that point on the graph. So to find the absolute value of an imaginary number, we use this formula. The absolute value of a plus bi is equal to the square root of a squared plus b squared, where a is the real part and b is the imaginary part. So let's get started with some examples. The first example, we want to find the absolute value of negative 4i. So notice this only has an imaginary part. I could rewrite this as the absolute value of 0 minus 4i because that 0 is the real part. So this would be like my a, my real part, and then the negative 4 is my b. Notice when I talk about my a and my b, I don't put the I in there. So like b is not negative 4i, b is just negative 4. So when we go to plug it into the formula now, we can say the square root of a squared. Well, a we decided was 0, so I'm going to put 0 squared, and I'm going to put 0 in parentheses, not because it's going to change anything in the calculator, but I want you to get into a habit of putting those numbers in parentheses because sometimes, especially when the numbers are negative, it does change what happens when you plug it into a calculator. So then plus my b squared. Now remember, we just talked about it. My b is just that negative 4. It's not negative 4i. So I'm going to just put negative 4 inside that parentheses and then square it. Draw over those absolute values, or that square root. Now I'm going to simplify that. So I have the square root of 0 squared. Well, 0 squared is 0. And then negative 4 squared gives me 16, which gives me the square root of 16. Now the square root of 16, good news, I know that that's 4. So my final answer, the absolute value of negative 4i is 4, which means, like I said, is that 4 is the distance between the origin on the graph and then the point on the graph, which again, we're going to talk about in the next video. Let's go through the second example. So the second example is the absolute value of 3 plus 2i. All right, so when we do the absolute value of 3 plus 2i, I'm going to say that 3 is my a and then 2 is my b. So I'm going to square root a squared, which would be 3 squared, plus b squared, which is 2 squared. All right, which would be the square root of 3 squared is 9, and 2 squared is 4. And then 9 plus 4 is 13, which means my final answer, because I can't simplify square root of 13, is the square root of 13. So that, once again, is the distance between the origin and that imaginary, or that complex number. All right, let's go through the third example. And the third example is, sorry, I lost it. There we go. The absolute value of negative 5 minus 7i. Okay, again, a is my real part, b is my imaginary part. So a is negative 5 in this case, b is negative 7. So I'm going to do the square root of negative 5 squared plus negative 7 squared. This is a really good one to understand. You want to get in that habit of putting the numbers inside parentheses, because negative 5 squared in parentheses like this, if I plug that into a calculator, it gives me 25. But if I just did negative 5 squared and plug that into a calculator, it'd give me negative 25. I want this way, because negative 5 squared in parentheses is like negative 5 times negative 5, where this way right here says I'm going to do 5 squared first and then just put a negative on my answer, which is not something we want. So when we simplify this, we're going to have negative 5 squared, which gives me positive 25, and then plus negative 7 squared, which gives me, oh, sorry, not 30. 7 squared is 49. All right. And 25 plus 49 gives me 74. Now, the square root of 74, I believe, can be simplified, but let's double check. Nope, it can't. So my final answer is just the square root of 74. All right. And then the last example says the absolute value of 12 minus 5i. Once again, your 12 is your A, negative 5 is your B, because that's the imaginary part. So when we plug it into the calculator, or the formula, it would be A squared, which would be 12 squared, plus B squared, which is negative 5 squared. All right, simplifying, 12 squared is 144, plus 5 squared is 25. All right, and 144 plus 25 gives me 169. I just had to double check that. And the square root of 169 is 13. So my final answer in this case is 13. All right, and that is how we find the absolute values of imaginary numbers.